大家好, I'm Nathan Rich, aka 火锅大王. A lot of people have been asking me for advice about getting into IT or how to understand computers. I started from very little computer understanding and climbed the ladder by myself to near the top of where the IT field can take you. While I didn't take the traditional route, I still learned some pretty useful tips along the way. If you're getting into IT or a computer-related field, you probably already have a few major problems to solve first. Usually, in the beginning, you may not know what exact angle of computers you want to do. Programming, IT, UI, UX design, or what? When I was a child, my mother sometimes brought me to work with her. Though computers were rare, I did see a few and tried to make DOS games work on them. I learned about the concepts of DOS memory management and sound cards. I was exposed to simple batch file programming and the general concepts of the newly released operating system, Windows 3.1. Then I learned QBasic, which came with DOS. This introduced me to concepts like flow control within a script. I built a simple program that made the computer speaker beep a part of Beethoven's Ninth Symphony. Later in life, when I started to get into computers intentionally, I learned PHP, which introduced me to the basic concepts of server-side versus client-side processing. My goal was to be a web programmer. I studied HTML, PHP, CSS, and JavaScript. But as time went on, I realized that web programming wasn't what I wanted to focus on after all. The point I'm making is that as you progress in learning computers, you may find your focus changes as well. That's actually fine. Nearly everything you learn about computers will be useful in some other field of computers as long as you learn the general concepts, because they can be so closely linked. So don't worry too much about exactly what you want to do in computers. You'll know it when you find it. The main drive should be to explore and learn. There was a time when I thought I knew just about everything there was to know about computers. Amusingly, this was before I started using Linux. I thought Windows exposed me to pretty much everything I needed to know. But the more I learned about computers, the more I realized how little I knew. And in this day and age, computer software is developed much faster than anyone can learn. So it's quite literally true. As time goes on, you know less about computers. How much less you know is all you can affect by studying. The second issue I know people face when they're learning computers is what I view to be the biggest one. This was a huge problem for me when I was starting out, and it resulted in a lot of wasted time. The problem is, even if you know what you want to learn, what's the best way to learn it? What stuff do you even need to know exactly? What software or language should you master? And which should you ignore? Should you focus on Java, or should you be learning how CPUs work? This lack of a general guide on what to do next was the single most time waster in my journey to computer knowledge. The problem comes from a lack of proper guidance, but it's made much worse by too few sources of general knowledge. Let me give you an example. Suppose you want to make websites. You've certainly heard of SSL and TLS, and you probably already know HTTPS means HTTP secure, and that there are SSL certificates and it has something to do with encryption. But the problem most new people face is that enough information? Do you know enough about SSL? Is that the right amount, or are you underinformed? The problem with this kind of thing is that if you, for example, look up SSL on Wikipedia, you find one of the longest articles you've ever seen, with tables and all these technical terms, and it just becomes an overwhelming task to try to understand. And you aren't even sure if you need to understand SSL better. This combination of problems for me was really difficult to sort out. In the end, I settled on the following approach. What I do is I try to find a simple explanation of a new subject. As I need to delve deeper, I do so by trial and error, reading documentation, and trying to find good tutorials. Good means by someone who both understands the subject and, more importantly, doesn't try to teach you everything at once. So let me tell you what the minimum level of SSL understanding that you as a web developer should have. SSL or TLS actually serves a few purposes, but in order to understand why it exists, we must first answer this question. How do you know that the website you've got in your address bar is the actual website you're talking to? How do you know that when you type bilibili.com into a browser that your computer is actually talking to Bijan? Your browser requests the DNS records for the name from the name servers you're configured to trust. An IP address comes back, let's say 1.1.1.1. Your browser connects to that IP and sends the header telling the server you're looking for a host called bilibili.com, and the server gives you the web page you've asked for based on that information. Okay, stop. I've already covered several subjects that each are black holes of information. You can spend a lifetime just devoted to the very few things I've brought up. HTTP, HTTPS, IP, DNS. This illustrates the problem. What I'm suggesting is you get a high-level understanding first, not drill down on each just yet. Okay, let's continue. Suppose someone had hacked the DNS server you use and told it to lie to you. Suppose when you asked the name server for the A record, it told you 2.2.2.2 rather than 1.1.1.1. Now you're talking to the wrong website, which may have made itself intentionally look like Bilibili, so you enter your username and password and they steal your account. So how can we stop this from happening? Well, we need a way to form a three-way relationship with that website and another service that we trust. We need to declare that this third party will be responsible for making sure we're talking to the right website. Those third-party providers are already configured in your browser right now. They are the authorities which tell you which Bijan is the right Bijan. But how does that authority know which one is real? Bilibili's servers are configured in such a way that if you talk to them without SSL, they redirect you to their SSL port. Their URL changes from HTTP to HTTPS, and they offer you a certificate. Your browser verifies that certificate with the third-party certificate authority, who tells your browser if it's the real site or not. But again, how does that authority know that it's the right certificate? Bilibili had to create a certificate request file on their server. That request is tied not to the IP address of the server, but rather to the host name. They send this file to the certificate authority, which issues an actual certificate based on that request file. The cert is next to useless by itself, but paired with the certificate authority checking you, you can be sure you're at the right site. But what else is needed to make this a secure connection? Well, encryption. The data you send back and forth between your computer and Bilibili's servers by itself is not private. Anyone on the network path can view it all, your passwords, your everything. So to prevent that, they redirect you to the SSL version of the site, which not only verifies the endpoints of the connection like we talked about, but also encrypts the traffic. It hides all the traffic in a coded way that can only be decrypted on two ends. That means anyone can still see what you're doing, except now it's just a jumbled mess and they have no way to descramble it. If you understand just that amount of information about SSL, you won't need much else to be a competent web developer. You can choose to go deeper, but that's all you really need. The problem I had when I was learning is it's really difficult to find a simple explanation like that, and someone to tell you how much you actually need to learn. It's a bit easier now that so many people have videos and articles online, but it's still not easy to find simply laid out information like this. Take a look again at the Wikipedia article for SSL. You can read the entire thing and still have almost no idea what SSL actually is used for in the real world. So my advice here is either find a good mentor to guide you through what you need to know and what you don't need to know about things, or really focus on finding a source online that clearly explains the concepts first. It will do you no good bogging down on things like SHA and RSA if you don't understand what the overall thing you're talking about actually does. It verifies through a trusted source that you're talking to who you think you're talking to, and it encrypts the messages from end to end. Once I started to approach things in this way, learning only what I thought I needed at first and moving on to the next thing, I was able to expand my knowledge faster and wider than ever before. If I wanted to focus on one thing more deeply, it was easier to do with the additional concepts I learned on other subjects. So anyway, when I finally did start to get into Linux, I began with Gen 2 Linux, which at the time was the hardest Linux I knew of. They've made it a bit easier now, but back then, especially for a newbie, it was really intense. Through learning Linux, I realized not only did I not already know everything there was to know about computers, I hadn't known much at all. I realized that software like Windows, OS X, and even some modern Linux distributions actually hide what's happening on a lower level and do damage to your ability to understand. And as new concepts came into my head, I thought about theoretical implications. When I learned about mounts, I started thinking about bind mounts. Could they be used to bypass file permissions inherited from parent directories? When I learned about IP tables with connection tracking, I wondered if I could use it to split my traffic over multiple internet lines to maximize my download speeds. Every little thing I learned, I tried to think of a practical way to use it. When I had finally gotten Gen 2 compiled a few times and was feeling comfortable, I set out to learn Linux more generally. For those of you wanting to do this, which I recommend for all computer-related fields, I highly suggest that you start by reading this book, Learning the Bash Shell. If I remember correctly, somewhere around 80% through the book, it gets bogged down on a bunch of long, boring exercises that it wants you to do. Don't worry about that stuff. Read and understand especially the first half of the book. And more than that, try everything it introduces you to. Don't just learn what awk is, experiment with it. Because the magical thing about the Bash shell and GNU tools is you find their fingerprints all over tools on Linux and elsewhere. For example, when you learn sed, you'll no doubt start to use this syntax, s/something/something else/g. But unlike so many specifics you learn on Windows, these basic tools are useful everywhere in Linux. When you use vim to edit files, you'll find nearly the same syntax in use, %s/something/something else/g. These types of fundamental building blocks are essential to working effectively in Bash. After I became the best Bash user I could, I wanted to learn real programming, so I went to the next natural choice, Perl. Perl is very easy to learn if you know Bash because it shares much of the same syntax. For example, in Bash, if you want to get the process's PID, you use $. And in Perl, it's also $. Without Bash, Perl would have been more difficult to learn. After Perl, I wanted a cleaner and more object-oriented language, so I moved on to a newer language called Python. Another reason I learned it is that at the time I was writing Kickstart scripts for use with a program called Cobbler. These scripts needed to run on very bare CentOS systems, which actually don't have Perl installed. But since Yum, the package manager CentOS uses, is based on Python, it's already installed 100% of the time, even on the pre-installed DVD environment. While it still annoys me sometimes with its obsession with spacing, it actually became quite popular. But you see, from learning Bash and Perl, Python was already pretty easy. It's building blocks on the way to excellence. Don't worry too much about what you want to do specifically in computers, but rather try to focus on how to learn the concepts of what these little machines are actually doing and how they think. That information will be more generally applicable and will come in much more handy than the specifics. Quite often in my line of work, I come across, for example, C++ developers who don't really understand the operating system at all. And occasionally there are some who do. Guess who really makes the best applications? The ones who understand how video cards basically work. They understand the basics of POSIX file systems and the difference between sync and async. They get why they shouldn't just use varchar 255 on every database field. And they know why. None of these relate to programming directly, but in reality they're the difference between a good programmer and a great one. Focus on learning for yourself, not for some certificate or to pass a test. Focus on understanding the subject deeply, and you're going to go very far in life. I can tell you that much. Thanks everybody. 谢谢.